In Chapter 5, we looked at just one numerical variable at a time. Now we're going to look at two variables at a time and see how they could be related. So often there is a relationship between variables if they're measured on the same individual. Remember when we were looking in the practice problem at the heights and weights of the Boston Bruins, we said that we expected that taller players would weigh more and shorter players would weigh less. So that's a relationship between the two variables of weight and height. In this section, we're going to look at scatterplots, which are a way to display visually the relationship between two variables. First, let's talk about types of variable. A response variable measures an outcome or result of a study. And an explanatory variable is a variable that we think explains or causes changes in the response variable. So as an example, we know that smoking can influence life expectancy. People who smoke more are expected to not live as long. So we would say that the number of cigarettes that a person smokes per day is an explanatory variable, and that their life expectancy is a response variable. To make a scatter plot, we're going to graph points that show the relationship between two numerical variables measured on the same individual. So we're going to make a graph that shows a bunch of points, and each point is going to represent an individual. We're going to have an x-axis that shows the values of the explanatory variable. So along the bottom horizontally we'll have the explanatory variable, and then vertically we're going to have the values of the response variable on the vertical axis. And then for each individual we're going to go up from their value of their explanatory variable on the horizontal axis and across from their value of the response variable on the vertical axis, and draw a point for each individual. So let's look at an example. A study at Ohio State University had students volunteer to drink a randomly assigned number of cans of beer. And this chart shows the results of that study. So for each student, we've got the number of beers they were assigned to drink. And then they measured the blood alcohol content of the students after they had drank their beers, and that's shown in this row here. So we've got two variables here. We've got the number of beers that the student drank, and then their blood alcohol content. And we would expect that the number of beers the student drinks explains their blood alcohol content. So the more beers the student drinks, the higher we would expect their blood alcohol content to be. So beers would be the explanatory variable here, and blood alcohol content, or BAC, is the response variable. So now let's create a scatter plot for this chart. So for each student, I'm going to put a point on my chart. I've got for my horizontal axis what I think is the explanatory variable, the number of beers that the student has drank. And for my vertical axis, I've got the response variable, or their blood alcohol content. So for the first student drank 5 beers, so I'll find 5 over here on my horizontal axis. And their blood alcohol content was measured at 0.1, so I'll find that over here on my vertical axis, and then go over from the vertical axis and up from the horizontal axis, and the point where those two lines meet is where I draw a point for that student. So I'm going to do that for each student. My second student drank 2 beers and had a blood alcohol content of 0.03, which is about here on my graph. My third student drank 9 beers, way over here, and had a blood alcohol content of 0.19, so almost up at the top of my chart here. My fourth student drank 8 beers and had a blood alcohol content of 0.12, which is about here on my chart. The next student drank 3 beers and had a blood alcohol content of 0.04, which is here on my chart. I have another student who drank 7 beers and whose blood alcohol content was 0.095, so very close to 0.1 here, just below that line. I have another student who drank 3 beers, and this student had blood alcohol content of 0.07, so that is higher than the other student who drank 3 beers, and that's going to be about here on my chart. Then I've got a student who drank 5 beers and had a blood alcohol content of 0.06, which is about here on my chart, so I'll put a point there. So I've done the first 8 students here. If you keep going and do the other 8 students, the graph will look like this. So I've got a point on here for each student showing how many beers they drank and what their blood alcohol content is. So now we know how to draw a scatter plot. Once we have that, we want to be able to describe the pattern that we see in the scatter plot. And we'll use the form, direction, and strength of the relationship to describe it. It could be possible that there are 2 or more trends or clusters in the same graph, so we'll keep that in mind. We also want to look for any striking deviations from the pattern. So these would be outliers that lie far away from where we would expect them to be from the pattern of the other points. Before we move on, let's review the concept of the slope of a line. So the slope of a line is the ratio of vertical change to horizontal change. And that's given in this formula. So slope is equal to change in y over change in x. So if I've got 2 axes here and I draw a line on my axes, then I can figure out the slope by looking at a section of my line, say from here to here, and drawing the triangle like this. So this is going to be, this is my y-axis and this is my x-axis, so this distance here is my change in y, and then this distance here is my change in x. So you won't have to actually calculate the slope of a line, but you should know what it is. So here are some examples. A slope is positive if the y values increase as the x values increase. So this would be an example on the left here of a line with positive slope. It goes up to the right. Slope is negative if y values decrease as x values increase. So that would be if the line goes down as it goes to the right. The slope is 0 if the line is completely flat and horizontal. And slope is undefined when the line is completely vertical. Alright, so using that information, let's move on. So let's look at the direction of a scatter plot. 2 variables have a positive association if their changes tend to be in the same direction. That means an increase in one variable tends to accompany an increase in the other variable. And 2 variables have negative association if their changes tend to be in opposite directions. So if I have a scatter plot that looks like this, I'm just going to draw a bunch of points here. I can see that as I go further to the right, my points tend to go up. So if I was going to draw a line that sort of represented the direction of this scatter plot, I could draw a line like this, it kind of looks like all my points go along that line. And that line has positive slope, so those variables would have positive association. If on the other hand I had a bunch of points that looked like they went down as I went to the right, kind of like this, then I could draw a line that follows those points that would look kind of like this. And that line has a negative slope, so those variables have a negative association. So let's look again. This is our scatter plot of beers versus blood alcohol content. And it looks like as I go to the right, my points go up here. So I could draw a line kind of like this through my points, and they seem to follow that line pretty well. So these are going to have a positive association between the number of beers that the student drank and their blood alcohol content. Let's look at another example. This is a scatter plot of the SAT math scores by state. And the mean SAT score is explained largely by what percent of a state's students take the SAT. So for each state, they looked at the percent of the state's seniors who took the SAT and also at the mean SAT math score for that state. And we have the percent of seniors who took the test as the explanatory variable and the mean score as the response variable. So this shows a negative association between the mean score on the math section and the percent of test takers for the class of 2010. We can see that the points go down as we go to the right here. So that's a negative association. You can also see that there are kind of two clusters of states here. We've got a cluster here and another cluster here. So in this cluster, we've got fewer seniors taking the test, and they have a higher mean score on average. And in this cluster, we've got more seniors are taking the test, and their scores are lower on average. So overall, we've got a negative association. Things you should know for this section. You should be able to understand the relationship between an explanatory variable and a response variable. So an explanatory variable explains a response variable. You should be able to create a scatter plot for two variables and then examine the overall pattern of the scatter plot and also tell if two variables have a positive association or negative association by looking at their scatter plot.